Thank you very much, Corey. This presentation is on behalf of the entire membership of the Lake Superior Technical Committee. Corey Kovacs, Corey Goldsworthy, and Ted Kaler all presented me with some information to share with you all today. Look at this. Here's an old school nav chart used as a backdrop. Some dark arrows here to show where some of the habitat projects are for this presentation. I'm not going to show every location of every dark arrow, but nonetheless, we'll take you through this little pictorial. A main takeaway from this slide, first of all, is the distribution of these habitat projects around Lake Superior. And they're mostly in the tributaries or near coastal waters. And that was a focal area in the rehabilitation plans for the various species 20 years ago. Second takeaway is the commitments made by the Canadian and U.S. governments providing funding vectors, specifically through the U.S. GLRI, the Great Lakes Restoration Initiative, and Canada's Great Lakes Freshwater Ecosystem Initiative. Those are funding vectors for a lot of these projects that you'll see today. We'll start off on the shores, north shore of Minnesota. This is by the Finland Area Office for Minnesota DNR. And they did a pretty good size, big scale thermal habitat connectivity project over the course of about 7 years, where 7 culverts were changed out, replaced, and more than likely upsized through various partnerships. And what these culverts did was establish more access to these thermal habitats for brook trout in specific. And so that resulted in a 95% connectivity effort there. Traveling down the shore toward Duluth on the far western side of the lake, Minnesota DNR out of the Duluth area fisheries office put together this campaign called the Roadmaps to Resilience. This is basically a collaborative assessment of climate and development related impacts to brook trout. And these projects were prioritized, targeted, and measurable, and that's what kind of made the difference here. The Tisher Creek one, and closer to the center, that one's completed, while the Buckingham Creek watershed is actually in the works. And turning over to Michigan's Buffalo Reef, many of you have heard this over the years. This is a threat to the whitefish and lake trout spawning habitat on Buffalo Reef. And there's a recent decision on what to do with the material for mitigation, and what's come out of it is there's the thought of trucking it or otherwise transporting these 12.2 million cubic meters of stamp sand materials to an upland location. And that's the current thinking of how this is going to be mitigated. There's just a close-up view of what the stamp sands look like. This is courtesy of the USGS webpage. Let's head over to Michigan, and you'll see the black arrow there where that's located in the upper left inlay. And that is Cedar Creek in Marquette. And a lot of these culvert projects that I'll talk about are basically expanding the area for fish to pass through, for water to move through, for sediment and wood. Because a lot of the times the wood can get caught in some of these smaller culverts and create these potentials for massive flood waves should the road crossing blow out. So you can see here in Cedar Creek and Marquette County, Michigan, you had 3 partners there indicated by the emblems, and that helped to restore the stream channel at that location. Turning over to the Hurricane River in Alger County, that structure there you see is, I don't have a before picture, but that is the after shot. And what you see is an expanded area, again, for water, sediment, fish, all things to transfer through there. I'm going to head over to Jader Creek, this time in Wisconsin. And you can see on the far left photograph, the before, the perched culvert there. And that's a real fish barrier, especially when it comes to the fish passability, basically what's called a jump height for these fish to pass through. And this is a cold water tributary in northwest Wisconsin. And the image there in the middle, this during shot, just gives you an idea of what it takes to replace a culvert like this and create this fish passage opportunity, this wood transport opportunity. In this case, this is what's called a bottomless arch structure. And if you haven't seen these before in the field, they're pretty impressive, because what you have to do is set the culvert on concrete footings, and you have to put those concrete footings into the ground, obviously, to set the culvert on top. And that's assembled in place. And that takes a little bit extra time, therefore there's more cost with it, and these structures are basically priced per linear foot. So the bigger and longer the culvert, the more it's going to cost. Turning away from culverts, this is an interesting project that Northland College led with some funding from the Great Lakes Commission. And this is on state land. The state of Wisconsin owns this property, and you can see the image there on the left, the before shot. These bluffs are sometimes 100 feet tall. You know, they're pretty huge, and what happens is the river runs right up against these bluffs. And what it does is transfers the sediment that falls off right into the stream, and boom, that gets transported downstream. In this case, in Fish Creek, there's a lot of spawning habitat for cold water species, trout, salmon, and the like. And a bigger aspect of this project was to reduce the sedimentation that flows into Chequamegon Bay. And that's a good 10 miles or so downstream, because there's an interest in Chequamegon Bay and the sedimentation that happens there for species such as walleye and the general ecosystem function there. So what you do is you build what's called a bench, and you can see that in the after shot. You see how distant now the stream channel is from the bluff slope itself, and that just gives those bluffs a chance to revegetate on their own without constantly being pounded by the energy of the stream flow. We're going to turn over now to Nebagaman Creek. This one has been in the works for about 5 years, one that I personally worked on and managed over these years. And this project is a railroad grade crossing from the logging era. The railroad pulled out around 1936 after about a 40-year stint of using it for people and for timber movement, and then left the railroad grade behind. So over time, what's happened, you can see right almost in the middle of the shot there is this failing, this collapsing of the railroad grade. There's a lot of sedimentation potential there. There's a potential for complete failure, and you can see also the potential fish passage impediment on the downstream side. I'm going to build this credits from the ground up as almost a grassroots approach to this project and removing this problem from what's in the storied Bois Brule River watershed to reduce the sedimentation potential there. And we had leaders from the Brule River Sportsman's Club, Brule River Preservation, and the Isaac Walton League all came together to meet with me. We've kind of formed a little committee to talk about how we're going to approach this problem that's been long-standing for actually decades. And with that, we started talking about funding mechanisms, who can contribute what can the state give. And one of the group members from these organizations decided to put together actually a GoFundMe page, and they called this the Brule River Rat Campaign. So if you bought something or contributed whatever, you get your sticker for your water bottle, your bumper, whatever it is, and that created about a $13,000 kitty. Very important match funds and stuff to show that there was a lot of public support for this project. Partnerships were also forged with the town of Brule and the county, Douglas County, and you'll see why here as we continue on. As we continued to develop the project and looked into funding alternatives and sources, we came across the potential for National Fish Habitat Grant, and that came through the U.S. Fish and Wildlife Service. Still continuing on in the development, who's going to do what for this project, something that the DNR was going to take on its own with its habitat crews. Turned out it was just going to be too much. So we needed some effort, we needed some thoughts about how to do this with contractors. Well, by the time we factor all that in, stream channel design, everything else, we needed additional funds. And many thanks to the Great Lakes Fish Commission and National Oceanic Atmospheric Administration pulled together a significant contribution to really top it off and make this project possible. Again, looking at the problem, this is a couple of pictures of the downstream end showing the fish passage impediment to species like coho salmon and also brook trout. This is a king salmon, Chinook salmon using the area. So downstream with the fish passage impediment, upstream is this impounding of the water. Anytime you get a backup of water, you get this potential pressure on the structure itself, and that can lead to a massive flood wave that just blasts on downstream and clears everything in its path. So we're trying to avoid that by digging into the structure, removing it, daylighting the channel, and letting things flow freely for the first time in about 150 years when this was first built. So the concern for collapse, that was the major problem. And this is an example of what happened at Little Balsam Creek in about 2018, where we had a pretty massive flood. And that you can see what happened there. There used to be 2 pipe culverts, and those plugged. Basically, the water built up, and essentially a failed dam. Sent the flood wave downstream. About a mile or so down, you can see in this other photograph with the person standing in the creek channel. That's about, I don't know, a little less than 2 meters tall individual. You can see how high that alluvial material from the road crossing basically settling there, creating a big problem for Little Balsam Creek, and that's cold water resource as well. Trying to avoid that entire situation and having to clean up a mess like that. So our geographic scope for this Nebagaman Creek project spanned about 2 miles. You can see the star on the bottom, which is our excavation site. We transport that over a township road, which was gravel and underlain by corduroy. So if you can imagine 50-ton dump trucks traveling over a corduroy road, you know what it's going to do to it. It's going to make a mess. But nonetheless, we coordinated also with the county, who gave us free access to its gravel pit 2 miles away, so we can truck the material. And you can see some details, some specifications that we'd have to address through the town when we use some of this material actually on the town road to strengthen it, to handle the trucking, to handle future trucking and road traffic after we were done with it. Here's the big stopper. Actually, the biggest hurdle of the project at the outset was identifying a landowner. Now, this is just a quick screenshot of a county map, and you can see a landowner is named to the north, had a big, long, huge pasture out there, cattle and everything grazing. Landowner to the south who was absentee, but nonetheless identified easily. But this question mark rectangle in the middle was a real stumper. And complexities of railroad law, reversionary clauses, that's the term I was looking for, in terms of who owned what land up to what part of the railroad grade. This was such a difficult thing to figure out. And if you're ever going to get involved with projects like this in railroad grades, just know you're in for a long haul. That if you want to work with the landowners who you think might own the property, that's going to be your top strategy. That ended up being ours, rather than go to the courts and identify who actually owns the property, because then you're going to be in for at least 10 years to figure that out. Fortunately, we weren't very interested in that. Nobody was. So our legal team at the DNR decided, well, let's get easements from the potential landowners. That included the former railroad company as well, which fortunately we tracked down. We were able to work with attorneys there to get the land use agreements. So it's great. We got through that hurdle. That was a couple of years in the works. It was time to design the channel. Hey, this is great. Let's just open it up. We're going to make big floodplains. We're going to make a bigger channel itself. That's going to be consistent with what's upstream and downstream so that the river flows as it should. However, once we identified the area as a mapped floodplain, this is a federal floodplain map that shows the floodplain boundary actually drawn into the culvert. So we couldn't make any changes to that floodplain map without some sort of authorization and agreement by landowners. Because what this was going to do, as much as it is important for the river to flow over, what's going to happen or flow through this new channel is it's actually going to raise the base flood elevation potential of a 100-year flood. And you can't do that necessarily legally in Wisconsin without some sort of easements. So you had to work with the landowners to get to this process as well. And we did that. It's just another checkbox to do. But nonetheless, it's just interesting that the floodplain maps were drawn through the culvert. So basically, to go forward without any type of easement for a floodplain, what we'd have to do is design a channel with that same exact constriction. And that just doesn't make any sense for river restoration. So we got through that. Finally, picking up on all these little bits and pieces of what the landowners and what the state needs. For instance, the access gate is decrepit and wrecked, and hey, what's going to happen with that, state? What are you going to do about it? You're going to buy us a new gate. Okay, simple enough. Let's work that into the land use agreement. Then we had the drill rig out there looking at soil composition, potential for contamination. The ATV there just indicates access across the river, because the river actually bisected one person's property. So once you take the railroad grade out, you can't get across. So we have to build a ford in the river so that an ATV can cross it. Then you got the state's wood turtles. Well, during the construction season, it's usually wood turtle habitat or spawning season as well, so we had to make sure we address that situation. The cows in the top, well, what's going to happen when you remove the big embankment? Those cows are going to have free reign to move wherever, so we got to somehow contain those. And then finally, the town's concerned about the road itself, and in this case, it does flood. So let's get into some pictures of the construction itself. These again are 50-ton off-road trucks, and one excavator was used primarily to dig this, and they worked around the clock almost 7 days a week, 10-hour days to move these up to 30,000 yards of material, or about 23,000 cubic meters of material. This lower right shot just shows you the size of this railroad grade once you start digging down, and at the base of the trapezoid, how wide it is compared to the stream itself. It's just some before and after shots. This is one you've seen previously in the presentation. Here's a during as it starts to clear out area for the new channel to form. And then finally at the end of the project, about 7 weeks later, this is what we have, a new daylighted channel. The culvert's removed, the floodplains are expanded. This is all erosion control matting, what you're seeing, but it's planted with new trees and ground cover and seeded and everything else there. So it's about a 7-week project and 6 weeks of actual work based on the rainfall that came through the area after a very ironically dry summer. A couple other looks at the project. This is just the top of the railroad grade and same view all the way through, and by the time it's all said and done, that is what it looks like from the top of the east side. And the feather in the cap is watching a just under, I don't know, about a meter long Chinook salmon decide to start making its way through the new channel. And in addition to that, this is just a picture of our contractor who, once we released the new channel, the water into the new channel, the old channel that was dried out, that fish was stranded up there. So he found it right away, grabbed it, and threw it in the river. Well, it's pretty exciting to see that. And that made his day. His entire family benefited from his exuberation after that day. So here are the drone photographs. This is compliments of Dennis Pratt of the Brule River Sportsman's Club. And it's really cool imagery. Specifically in the middle, you see that new channel starting to come together and how wide it looks. And that's only because of the groundwater inputs that are almost 5 degrees cooler than the channel itself. So we had a lot of groundwater in that area that was discovered simply by removing a lot of the pressure that was once on top of that water, otherwise not exposed. And my final slide here just shows the results of our partnership with the town of Brule. They provided road grading services as part of this project. It was an in-kind thing that really helped out. So you see the culverts on the upper right, and that provided additional drainage that we had to change out the original culverts. And finally, working with the county, who once our project was done, was going to reclaim it, seed it, and clean it all up. But nonetheless, you can see roughly how much material went into that gravel pit and how much we took up with it. I'll leave it at that. Leave it to Corey if we have any questions.
Thank you, Paul.